Here's our cam design motion analysis. We chose to create a roller follower because it creates less wear than a knife edge follower.
A flat face follower also makes the design cost efficient by using less material.
The function of our cam is to turn a hand crank water pump. As you can see here, our cam is attached to a hand crank that then turns the cam, which then in turn drives our internal piston up and down. As shown here, the hand crank is turned, which then turns the cam. As the piston goes up and down, it draws water in from the bottom and exhausts it out the top.
Inspecting the pump more closely, we can see exactly how the pump works. Water is drawn in from the bottom, which then pushes the valve and spring up. When the water tries to escape, the valve will shut.
A rubber seal on the piston ensures that all the water goes through the valve and no water escapes between the edges of the piston and the internal sidewall of the pump.
Setting up the pump and operating the pump is something that anyone can do. We specifically designed it like this because our target consumer for this product is going to be people living in third world countries that have no access to running water. This design requires very few parts, which not only saves money, but also reduces the chance of parts failing. If the parts fail, the design is simple enough that anyone can fix the problem.
The body of our pump is made out of cast iron. The shaft and the follower piston are made out of steel, and the springs in the follower are made out of brass. The handle on the crank is made out of oak, and there are rubber seals along the bottom of the piston and the bottom of the one-way valve.
Inspecting the interior of the body, we can see exactly how everything fits together. The piston fits tight against the interior walls of the body. This allows for us to get a maximum efficiency out of our pump, creating a higher pressure as it moves. The interior components are all made out of the material that are not prone to wear and corrosion nor fracture very easily under stress or strain.
Of our pump allows you to draw out water from the ground more steadily and controlled. A traditional vertical pump blasts water out in a very spontaneous manner, requiring there to be a stop in the flow of water.
The body of our water pump is made out of cast iron. The springs and cam are brass, the follower on top of the one-way valve are steel, and the seal around the follower and internal wall of the body is rubber.
The material we need costs $11. The labor costs $2.14 for each water pump because they're being made in China. Then the shipping from China to California costs $2.17 for each pump, making the sales price around $20.
Our design of a water pump is far superior to previous design because it combines all the advantages of a rotary pump as well as the benefits of an old-fashioned vertical pump and is more cost efficient.
Thank you for watching our video.